Algebra 2, Chapter 16.2, exercises 1 through 14. In this section, we're going to be solving exponential equations. I'm going to be doing in this video lesson the odd number problems, and we're just going to follow instructions. Solve the equations graphically. Here we have problem 1. We have 4e to the power of 0.1x equals 60. So what that's going to look like generally is this, and all these graphically are going to be this. We're going to have if we have a function y equals 60, there's going to be an exponential curve which is going to cross the y-axis at 4. There's going to be a solution right here. So we just need to graph this in the calculator, see exactly what this is. So I go to my TI-84 CE calculator and enter the equation on the left side of the equation, which is 4e, and e is Euler's number, which is approximately 2.718. It's going to be the power of 0.1x. So that's going to be one side of the equation. The other side of the equation is 60. And so if we graph, we see the first equation here, but we do not see the second. What we need to do is change our window. Okay, we need to change our window so we can see that second equation. So I go to 70, I will see it, and I'll just go ahead and graph it to see what this looks like. So we see the first equation, but we do not see it intersecting the second equation up here. So what we need to do is expand our window. So I'm going to take x max, set this equal to 40, and x scale by 5. And you can just experiment with this until you have an intersection point. And once you see an intersection point, you just have a keystroke sequence, which is second trace 5. Enter, enter, enter. So we get 27.08. So we'll call it 27.08, approximately 27.08. So x approximately equal to 27.08. And really, that is our answer. And our intersection point here is 27.08, comma 60. So that's what it was. Okay, let's go ahead and do the next odd number problem, which is 3. And here we're going to solve this one by setting, we have, we'll say y1, the left side of the equation is equal to 5, and y2 is equal to 625. E to the power of 0.02x. So let's go to our calculator. We have our left side equal to 5, and our right side equal to 625. E to the power of 0.02x, and we'll just graph and see what happens here, not change anything. I don't see hardly anything here, do I? I think I see the 5, but I don't see the 625 up here. So again, we're going to need to make some adjustments. What I'm going to do is make sure that my y max is at least 625. And so I'm going to make this 700. We're going to go by 100s. When you have a grid, a line grid, you need to be careful about your y scale and x scale. Otherwise, it'll really the graph will get really cluttered. So let's see what we have here. So we still don't see anything. It looks like we have our intersection point is going to be to the left of the y-axis. So let's go ahead and take this x minimum and make it negative 400. And let's see, I think we're going to x scale, I'm going to make x scale 100. Okay, here we go. So we can see, I hope you can see that we have an intersection point somewhere over here on the left side of the y-axis. And to find that what that is, we can go to second, trace 5, enter, enter, enter. So we get x equals negative 241.4. So and again, these are all approximately equal. So really with these, sometimes you'll have to hunt around for where the intersection point would be to find the solution. Okay, next set we have solved the equations graphically, then check your solutions algebraically. So let's go ahead and look at the odd number problems again. We have 450 e to the power of 0.4x equals 2,000. So we're going to enter y1 as 450 e to the power of 0.4x, and y2 is equal to 2,000. So again, going to our calculator, we have on the left side 450 e to the power of 0.4x, and on the right side of the equation we have 2,000. Now I know that I'm going to need to have the window set to at least y max to at least 2,000. I know I'm going to need that. Let me make it 3,000 just to make sure we have enough room. Okay, and I think we're going to probably have to adjust the x min, x max too. But let's just go ahead and graph it, see what we have here. Well, it looks like we do have an intersection point here. We can see it right here. Let's go ahead. I'm going to go ahead and restrict the x window here. So I'm going to go like from negative 10 to 10 back to a standard x extent. There we go. We can really see this quite well. So let's go to second, trace 5. Enter, enter, enter. So we get x equals 3.73, we'll call it. And it says check your solution algebraically. So let's go ahead and take this. I'm going to go ahead and work this out. 0.4x equals 2,000. So if we divide by 450, we have e to the 0.4x equals 2,000 divided by 450. And then what we can do is if we have the natural logarithm, which is log base e, and do this to both sides of the equation. So log ln e, which is log base e, of 0.4x is equal to 2,000 over 450. What we have is the ln, the log base e of e is 1, because e to the power of 1 is e. So we end up with 0.4, and I had to take the natural logarithm both sides here. Okay, so took the logarithm both sides, the left side. We're going to have to cancel out. We have to do this on the right side. And then, so we're on the left side now. The ln and e cancel each other, so we have 0.4x equals ln of 2 natural log of 2,000 over 450. And if we divide by 0.4, x is going to be equal to, so we have, we'll go to our calculator. So we have natural logarithm of 2,000 divided by 450, and we divide that by 0.4, we should get our same answer. Yeah, about 3.73. So on the right side, this is an algebraic verification of the graphical solution. Okay, next, another problem, which is 7. Solve the equations, give the exact solution and an approximate solution to 3 decimal places. And when we say solve the equations and don't give exact instructions on what to do it, I'm going to just go ahead and make an interpretation. I'll say solve the equations algebraically. So we're going to do that. So we have 6 to the power of 3x minus 9 minus 10 is equal to negative 3. So algebraically, we're going to gradually strip things away until we get this x by itself. Well, the first thing I'm going to do is get rid of this negative minus 10 by adding 10. So we have now is 6 to the power of 3x minus 9 is equal to negative 3 plus 10, which is 7. Next, what we're going to do is cancel out this 6 by taking log base 6 of 6. And what principle we're going to be using here is log base 6 of 6 is going to be equal to 1. So let's go ahead and write this out. Log base 6 of 6 to the power of 3x minus 9 equals log base 6 of 7. And so log base 6 of 6 cancel each other. So what we have left here is 3x minus 9 is equal to log base 6 of 7. And then we can add 9 to both sides of this equation. So I'm going to go ahead and bring this up here. So we have 3x is equal to log base 6 of 7 plus 9. And then we can divide by 3. So what that's going to give us is x is equal to log base 6 of 7 plus over 3 plus 9 over 3, so it'll be plus 3. So what we can do is we can use our change of base formula for this. So we're going to have log 7, I'll put x equals log of 7 over log of 3 divided by 3 plus 3. So let's go ahead and get this. Our log, I said log base 7, log of 7 over log of 3. How about log of 7 over log of 6? There we go. That's our change of base formula. Let's go ahead and write that, do that in the calculator. So we have I'm going to have 1/3. That's over 3, right? So let's do that. 1/3. 1/3 times log base 7, or log 7 over log 6. And then we add 3 over here. So 3.362 is what we're getting here. Let's see what we get here. Yeah, that's about right. That is exactly right. 3.362. So that will be our answer. I'm just going to box in this whole thing here. And this is one of these problems that you could actually verify graphically. Put this in your and graph each side and see if that checks out. Okay, problem 9. We have 11 to the power of 6x plus 2 equals 12. So I'm going to just write this out. 11 to the power of 6x plus 2 is equal to 12. Well, again, as we did in problem 7, we can take the log base 11 of both sides, because log base 11 of 11 is going to be equal to 1. So if we say log base 11 of 11 to the power of 6x plus 2, that's going to be equal to log base 11 of 12. And log base 11 of 11 is 1. So we have on the left side now 6x plus 2 is equal to log base 11 of 12. And subtracting 2 from both sides of the equation, we have 6x is equal to log base 11 of 12 minus 2. Now if we divide by 6, we have, this is what x is equal to. And we can use our change of base formula. So x is going to be equal to log of 12 over log of 11 minus 2 and divided by 6. So we'll just go ahead and put this in the calculator. So here we have our calculator. So we have log base 12, log 12 over log 11. And we're going to have, I guess we're going to go up here. And we're going to come up here and put minus 2. And we're going to divide this by 6. And we should have it here. We get negative 0.161, we'll call it. .161. So that will be our answer to number 9. Okay, we have number 11. We have 10 to the power of x squared plus 90 is equal to 105. I'm going to do two things at once here just to be economical. On the left side, I'm going to subtract 90 from both sides, and also 10 to the power of x raised to the power of 2 is going to be 10 to the power of 2x. On the right side, we have 105 minus 90, or 15. So what we can do now is we have 10 to the power of 2x. How do we get rid of this power of 10? Well, log base 10 of 10 is equal to 1. So I'm going to take the log, which is log base 10 of 10 to the power of 2x, is equal to log base 10 of 15. And so log base 10 to the power of 10 cancels, so we have 2x is equal to log of 15. Now dividing by 2, x is going to be equal to log of 15 divided by 2. So x, let's go to our calculator. We have log of 15 and I didn't get that right parentheses here. I think it's going to let me get by with it here. Over 2, I think we get 0.588. So that is good. Okay, next, and our last algebra problem is this one here. Solve. The price P of a gallon of gas after T years given by this equation. P equals P sub 0 times quantity 1 plus R to the power of T, where P sub 0 is the initial price of gas. And in earlier sections in our course, you've seen this basic formula. And it says, here we have our 1 plus R is what we call our base. And in this instance here, R is equal to 10.5%, which equals to 0.105. So our base is going to be equal to 1 plus 0.105, which equals 1.105. So our equation is going to be P is what we're trying to find out, and it's going to be P of T I'll call it P of T is equal to P sub 0 times 1.105 to the power of T. So it's asking how long it'll take. Let's go ahead and we want to go from 3.25 initially to $4 a gallon. So 4 on the left side is equal to 3.25 times 1.105 to the power of T. And we divide by 3.25. And what we get is 1.105 to the power of T is equal to 4 over 3.25. And so what we can do is take the log of both sides. Because the graphic, I don't have a lot of room here. It would help with this graphic, we're not here. So we'd have this log of 1.105 to the power of T is equal to log of 4 over 3.25. And using the property of logarithm, we can multiply this T out front here to get T log 1.105 is equal to log of 4 over 3.25. And then if we divide by log 1.105, we will have our answer. So I'm just going to do this to the right. So T is going to be equal to 1 log of 4 over 3.25. Let's go to the calculator. So we have log of 4 over 3.25 over log of 1.105 and that's going to be equal to about 2.08, we'll call it. So say we'll call this a little over, it's asking how long will it take? A little over 2 years. So that's what we'll call our answer for this one. Okay, and then number 14 is this one here. Similar type problem here. For 14, it says how much to take the $600 to triple. So you can let a sub 0 equal 600, and then to triple, that would be then a sub t, our final amount, is going to be 3 times that, or 1800, and just kind of work out that equation that way. Well, that's it. Good luck, and thanks for viewing.